Good morning.
Good morning.
So far, we have already discussed about the velocity time graph, and in this lecture, I will discuss you about and very interesting aspects of this velocity time graph. As we know that from the calculus that velocity is defined as the rate of change of displacement dx by dt. dx by dt. If we plot if we plot a velocity time graph, that is at the x-axis we are going to plot the t, and at the y-axis we are going to plot the velocity v. Let us consider that at certain time it starts with velocity u, and this will be the constant velocity. So it will be the parallel line towards the x-axis, parallel towards the x-axis, and this will be represents the time t. This will represents the time t. The interesting aspect of this velocity time graph is that the area of the velocity time graph represents the displacement. Very interesting aspects of this velocity time graph. That area, this is the area. As we know that the area of it is a rectangle, and the area of rectangle is equal to length into breadth. Area is given by length into breadth. In this case, we are looking here that at the time 0, the velocity is u, and at the time capital T, the velocity is t. At the velocity is t. So the velocity will be the OU into t. The area of the rectangle OU, let us name this OUB. T is equal to area will be given by OU. Area is equal to OU into OT. OU into OT. It means U into T. This is the time. This is the time which is represented on the x-axis. U into T, capital T. That is area barabar U into T, and U into T will be will give the displacement. It is very interesting aspect of this velocity time graph. How it is happening? We note the dimension. Dimension of U is given by capital L, rate of change of displacement. Dimension of U is equal to L by T, and dimension of T is equal to T, and this is your cancel. This T and T is cancel out. That is dimension of the dimension of the dimension of the dimension of U, velocity U is equal to L by T, rate of change of displacement. That is U into T, and L by T, and dimension of capital T is capital T, and dimension of T is equal to T. So T will cancel out, and which is the dimension of displacement. So it is very interesting aspect of this velocity time graph, that area will give the dimension of the displacement. Area will describe the displacement of the velocity time graph. Thank you.